thank you for coming. Thank you for not only attending Pi Gotham, but getting up early and coming to attend my keynote. That's sometimes a hard thing to do, so I appreciate it. So again, I'm Kojo. This morning I'm going to be talking about something that I call the Python use spectrum. Here's a little bit of biographical information about me. I am one of those career change people. So I used to be an accountant and a university instructor, and now I am a Python developer. I'm also someone who's going to start the timer on his watch because that's important. So who else am I? There are a bunch of different things I do. As Paul pointed out, you might have seen me somewhere before, partially because I have spent a certain amount of time being mildly ubiquitous. So I am one of the organizers for DjangoCon US, and I also try to do a certain amount of DevRel for them. I am also the DEFNA North American ambassador. So DEFNA is the Django Events Foundation North America. That's the nonprofit that actually has been putting on DjangoCon US since 2015. And in that role, I sort of travel around the North American continent, nominally the North American continent, sometimes other continents because I'm out of control. But basically to let people know that DEFNA exists and that DEFNA has small amounts of funding for Django-related events in North America. So if you have questions about that, you can go to the DEFNATO Twitter account or defna.org for more information. Also to remind you that DjangoCon US could come to your North American city in the future. There'll be more details about that later. I'm also here to sort of extend an official hello and group hug to the Pi Gotham organizers. So as a conference organizer for the past, 4 years now, you meet other conference organizers. And so here's my literal and figurative group hug from both the DEFNA board and the DjangoCon US team. So hello to everyone. So what am I talking about today? I'm talking about this Python use spectrum, and the motivation for this is to try to remind people that Python and other Python projects are open source projects. So I gave this talk initially in January 2019, and it ended up becoming a bit more contentious than I expected. So the main point of the talk got lost in the fact that people were arguing about how people should be writing code. But the point of this talk is to remind people that, again, Python is an open source project, and what does that really mean to be an open source project? And also a reminder that Python is growing in use, and so we definitely see an uptake in Python usage, but are the number of people contributing to Python growing at a similar rate? And so that's sort of what this talk is about. So with any open source project, and also, how many of you, just by show of hands, attend a meetup group, some sort of Python user group meetup in your, okay, so I see roughly half the hands go up. So now, have you all ever seen, or something analogous, have you ever run into a problem where you needed more speakers? You ever had trouble trying to find a speaker for your meetup? So, exactly, so a similar number of hands go up. If you're running an open source project or running a meetup, there's always this idea of needing more help, needing more people to contribute to it. Open source projects, very much the same as meetups. So with Python being an open source project, what does that actually mean? One, as was pointed out about this conference, it is almost entirely a volunteer effort. Despite the large amount of money that gets generated from Python and businesses that are built on it, the Python language itself, largely a volunteer effort. The people who make and maintain and distribute Python, almost all of them are doing it in their free time unpaid. So I'm focusing mostly on the Python core language in this talk, but this relates to things like Django and Flask and other Python-related projects. So when we talk about contributions, the contributions aren't just code. Often the code is what gets highlighted because, of course, you need the code to make the Python interpreter run, but there are a lot of other things that go into a project. And a project the size of Python isn't just a coding project. It's not just a personal programming project. It is much closer to being something like a business than a hobby. And as a result, it needs more than just updates to the code base so it can both survive and grow. And then as it grows and continues to grow, the needs of the project expand beyond just the initial code. And so if you look at the contributions I have listed here, most of these things are not covered in your typical computer science program or in a coding bootcamp. And so if you have a project that is made entirely of people who are primarily software developers, you're going to be missing a lot of these skills and abilities, but they're still needed. So when we talk about help wanted, it's not just a want. The past year or so has brought a lot of change to the Python project. So Guido van Rossum, our former benevolent dictator for life, has stepped down in July of 2018. He left the governance decisions to the core developers, and as a result, a steering council was created to help guide the project going forward. And so you have this 5-member steering council that will lead the council. So the governance of the project itself has changed. And you can find more detail about that here. PEP 13 lays that out and will describe the process in more detail. I'm not going to go into it here. But the reason I bring this up is because of this. The people who sort of figured this solution out and are now having to implement it were also the core maintainers. And so the same people who are doing most of the actual technical heavy lifting to make sure that there is a Python 3.7 and 3.71 and 3.72 and 3.8 and so on and so forth, we're also having to figure out, okay, well, how do we govern this project? And so, again, mostly volunteer, mostly people in their free time, not only having to figure out how to make Python continue to exist, but also how to figure out how to govern a very large open source project. And so, in addition to having now the core maintainer role, but also having to work out governance and then enact the governance, you've got lots of hats being worn by these people. And again, burnout is a very real thing. So the volunteers have to take time off from their open source commitments, and I have been fortunate enough to meet more than one of the core maintainers at different points as I wander North America and the globe. And so I'm not here to sort of point out individual names because that's not the point of this. The point of this slide and this portion of the talk is to draw attention to the fact that people need to take breaks from their volunteer activities when they're overwhelmed by the workload. And we've got a certain subset of people who are being overwhelmed by that workload. And this isn't happening just with the Python core language, it happens with other high-profile Python projects as well. And so the way to sort of help ease this workload would be to have more contributors. So the more contributors you have, the more people you have contributing, not only do you get a wider range of expertise, if we go back to this set of contributions, not only do we have people with a wider range of expertise, but we also just have more people in general to help ease the load so the work can get split up. And so the question is, where do we find this help? Who are these new contributors that I'm talking about? So when we talk about people who might actually become contributors, there are two necessary conditions to become a contributor to the Python community. One is that you have to be someone who uses Python to solve problems or see some value in it. And when I say requirements, I don't mean you won't be allowed to unless you meet these requirements. I mean, you wouldn't even consider doing it unless you meet these requirements. So one, if you're not using Python to solve problems or don't see any value in Python, why would you ever actually try to contribute to Python? So we have to find people who are doing that. Two, those people have to feel included in the community, feel like they're welcome and valued enough to actually make contributions to the community. So again, if you're using Python, but you don't really like the Python community or don't feel comfortable in the Python community, again, why would you use your free time voluntarily to do free work for people that you don't necessarily care about? And so if my use of the word sort of feel puts you off, again, how much time would you spend trying to help people that you don't really like? I also point that out because it's one of the few levers that we as members of the Python community can actually control. How do new people feel? How welcome do they feel when they join our community? So again, the emphasis here is on the word might. Again, meeting those two conditions, finding value in Python and feeling actually like you're a member of the community, that doesn't guarantee you're going to automatically become a contributor. It just puts you in the pool of people who could become, or who might become contributors. And so where do we find these people? Where do they come from? So I'm going to focus first on this, on the first criteria, people who use Python to solve problems. So the good news is that Python is growing very quickly. As I think many of us know, it's one of the most popular programming languages. So what this means is there are a lot more people who are now actually using Python to solve their problems. So that first condition is being met by a much larger number of people. And we have some actual data about this. Here, if you're not familiar with TIOBE, the TIOBE language index, sort of a ranking of the popularity of programming languages. And we can see that Python was the TIOBE language of the year in 2007, 2010, and 2018. Language of the year means that its popularity grew faster than any other language in that year. So we have these spikes, so we can see that Python's popularity is growing, and that means more people are using Python. The question then is, how are people using Python? And this is where we get into sort of the second category. So the growth is fantastic, but everyone's not doing the same things with Python. So this is what I call the Python use spectrum. And we look at sort of this continuum of the different ways people use Python. There are multiple ways to write code, multiple reasons to write code. So how you write code is going to depend on why you're writing it, who's going to be using the code, and how it's going to be run and where. And so again, I refer to these sort of different ends of the spectrum as programming and software engineering, and I'll get into my definitions, details around my definitions here in the next slide. So I make this distinction between programming and software engineering based around a few different things. So one, who writes the code? In a programming style of writing code, code's often written by individuals. Whereas in a software engineering perspective, code's usually written in teams. So software engineering generally refers to what we think of as either professional, quote unquote, software development, or contributing to open source projects. So in a programming style, who's running the code? The runner of the code, the runner, or who's going to be running the code, or who's going to be reading the code after it's written. In a programming approach, it's usually the author, because you're working by yourself, you wrote the code, you're going to run the code. If you need to look at the code later, it's just going to be you, the individual. In a software engineering perspective, other people are going to be running the code, and if someone else needs to look at the code later, there's a good chance it's going to be someone else on your team. It might not be just you. In a programming style, if you look at, how do we expect the code to actually be run? If you're in the programming paradigm, the code is going to be run with supervision. The person who wrote the code probably running the code and looking at it while they're running it. Whereas in the software engineering perspective, the code is generally expected to run in isolation. The code, you just ship the code off somewhere, it should just run. You shouldn't need someone to watch the code while it's running. It's expected to just run. Then what are you actually after? Why are you writing the code? What do you want? With the programming style, often you're writing code to solve a problem, so you don't really care about the code. What you really want is the output of the code itself. You're not after the actual code. In the software engineering style, the code itself is the product. So you're going to ship this finished code somewhere, and the code itself is the product. And as far as the motivation, why you're writing code, in the programming paradigm, you're usually writing code for some sort of utility. You're trying to solve a problem. In the software engineering paradigm, you're writing code because you are a professional writer of code. And so you've got these two sort of ends of a spectrum, but they're very different use cases for how one goes about writing code. So the big takeaway from this is that you've got these different use cases, and they require different sets of tools. Now, the point of the prior slide, and I've learned that I sort of have to make this point, the point of the prior slide is not to make some sort of distinction between like real developers and not real developers. That's not a thing. If you've written a line of code and that line of code did what you expected it to do, you're a real developer. Congratulations. Please, we hope to see you at the next meeting. Your decoder ring is in the mail. We hope that you will bring a snack or a beverage. So welcome to the club. But the point is, there are two very different styles of building software. Almost everyone who writes code starts in the programming style. And then based on their needs and their goals, some of them may move towards the software engineering style. So people like myself who were career changing, trying to become hired as software engineers, we needed to move more towards the software engineering end of the spectrum. But then there are lots of other people who have uses of code where they don't need to move very far. I'm gonna use my laser pointer. Some people start here, and their goal is to move all the way here. Other people start here on the programming end. For the people watching on video, I don't think the laser pointer is gonna be visible to you. Uh-oh, something is beeping here in the hotel. Hopefully that means we're not under attack. So you might start at this end of the spectrum and then get to, a quarter of the way along the spectrum and find that's all you need and stop. So I'll go into more detail about that later in the talk. But again, there's a different set of tools that you might need if you're a programmer versus a software engineer or where you are on that continuum. So let's look at some of those tools. When I talk about these software engineering tools, let's take a look at those. Again, one of the big things here is that we have programmers, we have software engineers, we also have sort of data science folks who might be somewhere in the middle. Let's take a look at some of those tools that I'm talking about, some of the software engineering tools and practices. So what I've got listed here are some of the tools and practices that software engineers need to be familiar with. Again, if you are writing code in teams that is intended to be run by other people, and you're doing that as your profession, and the code itself is the primary product, then you need these tools, version control, documentation, these tools are necessary for software engineering, but they're not always necessary for programming. And so what is the problem that I'm sort of pointing out in this talk? What do I think is the issue here? The problem that I'm pointing out is that in our community, in the Python community, our culture is heavily biased towards software engineering as the one true way to write code. And people who might not be using all those tools and techniques are sometimes viewed as doing it wrong or not being technical enough or something along those lines. And as is hopefully obvious, and if it's not obvious now, I'll make it painfully obvious later, that may inhibit people from joining our community and becoming contributors. So let's take a look at some history now. So now it's time for Old Man Story Interlude as we talk about the history of Python. So we're gonna go back to the Bronze Age of Python. I'm gonna take a drink of water here. As you're an old man, you talk a lot, your throat gets dry. So back in the old days, with my prospector voice, I call this sort of the Bronze Age of Python. And so Python was first released in 1990. I have relatively recently become a developer, but I first got exposed to Python in 1998, 1999. So the first version of Python I saw was 1.5.2. And so back in the sort of the Bronze Age of Python, I distinctly remember how Python was being discussed by other programmers. And I remember going to Barnes and Noble. If you young people today with your fancy ebooks and internets, might not remember the bookstores because they're not really a thing anymore. But I recall going to bookstores and seeing, going to the computer section and seeing all sorts of books talking about programming languages and seeing how Python was called a scripting language. It wasn't even called a programming language. And there this whole set of things about, Python is a scripting language. And if you wrote Python code, you were scripting. You weren't programming because it wasn't a programming language. A real programming language, for grown-up people, was something like C or C++. And you would use, you were using the Unix shell or something like that. But Python was referred to as a scripting language, and Python code was referred to as scripts, not even programming. And real software engineers kind of like, ha ha ha, Python, it's so nice. You can use it to connect real software together, but it's not real programming, it's just scripting. And but at this point, Python was popular enough that it was being talked about, maybe in slightly derogatory terms, but it was being talked about and it was gaining traction, and there were books being written about it. And in this time, we moved from Python 1 to Python 2, so things were going well. Now we move into the golden age of Python. And so if you've been doing Python over the past 10 maybe 15 years, you have largely lived in the golden age of Python. So in the golden age of Python, Python 3 has not only been released, but it's also been around long enough to actually gain some traction. So people are using Python 3. There's still legacy Python 2 code out there, but Python 3 is actually starting to pick up use for new projects. In this sort of early phases of the golden age, Python is starting to be used as the computer science one-on-one language in lots of universities. It's replacing things like Java and Pascal, much older, but Java and Pascal. Django and Flask exist in this time. So it's being used so Python now is starting to be used for actually quote unquote real programming tasks and for software engineering. People are building web applications. The web economy has helped this. People are building serious internal tools with Python. And as a result of this, the community culture starts to shift towards software engineering as the one true way of writing code as people become more serious about Python. Anything else is considered kind of nonsensical, beginnerish. And so as the golden age of Python enters, we've forgotten our Python history. So we went from being laughed at by software engineers to then becoming the software engineers who were laughing at other people who weren't using all the software engineering tools.
Woohoo! Yeah!
I'm not sure that that's the right response. So why does this matter? It matters largely because, again, if we have a bias towards software engineering, it often leads to a bias against the programming style of writing code. And how this really becomes an issue is that data science showed up. And so we know that data science is one of the things that is driving the popularity of Python. Not the only thing, but it's definitely one of the things. the nature of the Python language makes it very accessible for people who are newer to coding. But with data scientists, for instance, don't always need all the software engineering tools. But when a data scientist asks a more experienced Python developer, who's often a software engineer, for questions, many of us will tell them that they're doing it wrong because they're not using the full tool set. So you have a large number of people new to Python using Python to solve problems who, when they interact with our community, have a bad experience because they're being told that they're doing it wrong because they don't have Travis set up. And maybe that's not what they need. And as a result, they stay on the fringes of the community. And so they're using Python, but they're not necessarily going to become contributors. And so while data science is sort of like the big obvious example, there are lots of other use cases for Python that don't require the full set of software engineering tools. Again, Python's accessibility, its readability, and the clean syntax make it a great way for people who are new to programming to use it to solve problems that they have. But again, those people don't need the full set of tools. To use the cooking analogy, Python lets you actually cook things without forcing you to become a professional chef. And so this is very useful. When we look at those tools, again, we see this slide that I showed earlier. If you are trying to use Python to solve problems that you have, in that list of software engineering tools and practices, the ones that are highlighted in yellow are the only ones that are actually required. So to cook with Python, you have to know where you're expecting your code to run and what you need to run your code properly. So dependency management and knowing your development environment are the only things that you actually need to solve problems with Python. And you might have that solved by just getting Python installed. Because if you don't need to install any external libraries, just installing Python and knowing how to run Python may give you all the tools that you need. And so let's take a look at some examples of how this plays out and how people might move along the programming spectrum, the code spectrum. So I'm going to start with myself because I know myself the best. And also I've moved along the spectrum here. So we look at point A here. Here in point A, this is me when I'm first starting to learn to code seriously. Using as an example a project that I wrote, something that I built in my last accounting job where I was writing code to solve a problem I had. I was trying to automate some stuff with spreadsheets to support my current profession. I knew that I had an interest in becoming a software engineer, but at that moment, I didn't need the full set of software engineering tools. So I was learning to write code that solved a problem. To move on to point B here, the wrong button. Move on to point B here, and this is where I am now trying to practice some of my software engineering skills because I know that that's a goal. So I start using Git and adding documentation to the project to support my profession. So I'm not, but I'm also trying to teach myself software engineering tools because I know that's my goal. We move to point C. We take a look at a project that I built, just again, trying to advance my software engineering tools, using the Twilio API to do some things with text messages. So I was using Git, I was using the Twilio API. I'd written a few tests for this project because I was using something weird with regular expressions. Ended up having to deploy the project, well, needing to deploy the project, so I used Heroku for that. And so I'm moving further along the software engineering spectrum because again, that was my goal. And then at the far end D, we find me in my current software engineering job where I'm using a variant of this original project, but it's now going to be an internal tool that should be usable by the rest of my team. And so I've Dockerized it and sort of added the full suite of software engineering tools to it because it's expected to be used in a software engineering environment. So this is my journey along the Python use spectrum. Let's take a look at someone else, what we call a data-heavy professional. This is someone who already has a profession. So maybe they're an accountant, maybe they're a geologist, maybe they're an engineer, maybe they're a chemist, and they're doing some sort of data analysis. They're wanting to write code that will help them with their current profession. So maybe here at point A, when they're getting started, they're running that code on their laptop to support the current profession. They've got a problem, they want to solve it with code. That same person, they move along to point B, they've learned a little bit more about code, but they've realized that, you know what, it would be nice if I could branch this code off. Like, I've got this code working, I want to make a change to it, but I don't want to break it. And so a helpful software engineer tells them about Git, and so they use that, they start adding that, they add that a tool to their tool set. Again, they're not trying to become a software engineer, but they just realize that this particular software engineering tool can help them in what they're trying to do to support their profession. And then They move to point C, and in point C, that person now has more Python knowledge. They don't need any new software engineering tools. They just learn more about Python to help them solve that particular problem to support that profession. So again, their coding skill increases, but they don't need to move any further along the spectrum because they don't need any more software engineering tools for what they're doing. This could also be a data scientist, or it could just be someone who wants to make their job easier. So let's look at a third person, the person who just loves to write code because they think it's cool and awesome. So that person, they learn to code maybe using the Think Python book that's available free online or some other free resource, and they just enjoy coding. They move on to point B, they become a more experienced Python coder, and they think, oh wow, this is fantastic. Maybe they decide they want to make games and run them on their laptop or show them to their friends. I see you, Pepper. So they're just learning more Python. But again, not learning any more software engineering tools because they're writing code that runs on their laptop they can show to their friends. They get to point C here. It's probably too low on the slide, shame on me. They move on to writing more code, and maybe they find out they can write code that pulls data from web APIs, and they can do cool things with that. And they think, well, this is fantastic. I really enjoy this. But again, they don't need any more software engineering tools. They're just writing code. So what's the common denominator here? So all three of these different people are using Python as a solution. They're using it to solve problems. All three of these people are potentially contributors to the Python ecosystem unless they meet a more experienced Pythonista, a software engineer who is like, well, why don't you Dockerize this? Why are you a terrible person? Stop it. So again, the only people who will ever consider contributing to Python are people who see some value in Python and also feel like they are members of the community. So to move people from potential towards actual contributors, again, we need to make sure that these people are being embraced in the community and not being told that they're wrong. Back to the cooking analogy, most of us have a friend who's an excellent cook, but if Gordon Ramsay were to show up in their kitchen, he'd just cuss them out and call them all sorts of terrible names, partially because that's what Gordon Ramsay does, but also partially because they're not using the full set of professional chef tools. But again, that's not always needed. So something I'm going to point out here that relates to this is Russell Keith McGee's PyCon 2019 keynote. And so if you were not at PyCon 2019 or haven't had a chance to watch this, I highly recommend it. It's an excellent talk looking at the future of Python. I'm just going to sort of cherry pick certain parts of it, but it is hard to not recommend most of Russell Keith McGee's talks. And so, so it's hard to go wrong with Russell in general. But some of the things he points out here in this talk that I'm going to focus on is this idea of finding professionals who have the skills that the project needs and actually paying them to support Python. And then also building a team with contribution skills that are beyond just code. So I'm going to click through some screenshots here. I took the mildly lazy route of taking screenshots partially because it lets you see what's going on in his slides, but also it fixes the attribution problem. So it's Russell Keith McGee, keynote, PyCon 2019. So one of the things that Russell points out is that money makes things happen. If you're trying to have things done in your project, having some sort of funding or having some sort of money coming in for the project is important. And that's because expertise actually costs money. And so if you want people who have expertise to help you with your project, experts are accustomed to being, or skilled professionals are accustomed to being paid for the work that they do. And Russell also talks about some of the different things that are needed. Project management, UI, UX design, developer relations, documentation. And then so this set of things may be slightly obvious to a software developer. It's like, okay, if I have software, I want it to look well. I want it to function well. And I need documentation. But some of these other things are slightly less obvious, especially for larger projects. Organizing conferences. If you speak to your conference organizers here at PyGotham, they will point out to you that this is not a trivial thing to do. Legal advice, communications and PR, fundraising, strategic deals. Many of you may know that the Humble Bundle fundraiser for the Python Software Foundation recently ended. Who made that happen? Was it someone? Did that happen because somebody went to Python and typed import fundraiser? No, that's literally not a thing. Much like import anti-gravity. As much as we'd like both of those to be things, they're not things. So who handles these things? And so what stood out to me as I was watching Russell's keynote at PyCon this year was that while it's true, skilled professionals can contribute to the project and having money to pay them would be fantastic, skilled professionals have options. And so if I'm someone who has these skills, again, I've been working on this talk for over a year, on and off. And so what stood out to me during Russell's talk was what separates the Python community from any other potential client that a skilled professional could go to. Everyone else's money is just as green. And so if I could work for the Python Software Foundation, or I could work for, say, a doctor's office or some medical group or something else, in choosing between clients, like the person who is actually considered a member of the Python community or feels included in the Python community is much more likely to help us than someone who does not. So again, as an analogy, if you go to a doctor friend and you have a cut and you tell them, oh yeah, I just put a Band-Aid on it, is that doctor friend gonna look at you like, what? You put a Band-Aid on it? Why didn't you just use surgical glue, noob? Like, I mean, what kind of, why aren't you using like the professional tools that I use? That's probably not a thing that's gonna happen with someone talking to their friend who's a doctor, but unfortunately, it might happen to someone who's using Python to solve a problem who talks to a friend who's a more experienced software engineer. So what's the call to action here? I'm not just trying to sort of provide a lot of doom and gloom and scold people and shake my finger, despite my old man story time. First, it's important to recognize that there are different styles of writing code, and that when you're talking to someone who's learning to code or who's trying to figure out how to solve a problem with code, if they're stuck on something and they come to you for your help because you're an expert, don't tell them that, that they need to learn how to use Git or Docker or continuous integration unless that actually solves the problem they come to you with. But unfortunately, I've run across a number of people who feel like it's too much of a hassle. You become accustomed to your software engineering paradigm, and if someone wants to try to run some sort of code in a way that's not in the paradigm that you're accustomed to or that you're comfortable with, they feel like it's too much of a hassle. So if you're interacting with someone who is newer to code or is writing code not as a software engineer, try to actually listen to the problem they have and try to help them solve that problem specifically. Don't try to overlay a bunch of software engineering tools on it, because again, not everyone wants or needs to become a software engineer. So know your audience. This kind of thing can help draw new people into the Python community, because here's the reality about Python. It's an open source project, probably will always be an open source project. People can download Python for free and just continue to use it and solve their problems. If they interact with, and I'm saying this to Python software engineers, people who consider themselves professional Pythonistas, if they interact with a more experienced Python professional and that person sort of tells them they're a noob because they're not using Docker Compose, those people will just sort of go away, go off to the side. They'll continue to use Python, but they won't, why would they contribute to it? It's like, I met some of these Python people, they were terrible. So no, I'm not gonna volunteer my free time to help those people. So this is something to be aware of. Here I have some, instead of FAQ, I made up my own thing because this is real. Frequently heard comments and questions. So they're not often questions, but also often comments. So some people say, well, but Kojo, everyone can benefit from, insert the name of your preferred software engineering tool. Yes, that is true. Everyone could benefit from Git or from Docker or from continuous integration or continuous delivery. That'd be fantastic. The question is the cost of learning this new software engineering tool, is the cost of learning that truly less than the benefit of using it? And does the person that you're speaking to really need that tool? Or is it a tool that you become accustomed to and that you're comfortable with, and so you think everyone should be using it? I've also heard, there we go. I've also heard this sort of comment or question of, do we want people in our community who aren't willing to learn the hard things, the quote unquote hard things? The answer there is yes. Partially because everyone doesn't need to be a software engineer. Everyone doesn't need to learn all the details of software engineering depending on what they're doing. And also, let's not forget about the idea of bringing new skills into the community that we need that don't exist within traditional programming backgrounds. And then, from a reality check / humility standpoint, as people running an open source project or involved in an open source project, we are literally the beggars who can't be choosers from the standpoint of we're asking people to do free work, free voluntary work that benefits us. So you can't, it's hard to be sort of overly high and mighty with that. And then this last thing, okay, So people have said, so we should just be nicer to the newbies. So first, stop using that term. Again, you're back to old man story time. I recall hearing the term newbies early on, and it was a term that basically computer nerds made up. This is back when being a computer nerd wasn't as cool as it is now. It's a term that computer nerds made up to make themselves feel and seem cool around people who weren't computer nerds. Instead, focus on using your experience and your expertise to actually help the person that you're interacting with solve their problem, not to try to drag them down the road to software engineering if that's not what they need to do or if that's not where they need to be. So the conclusion here is, again, it's a volunteer project. We need to encourage as many it's a volunteer project and it's growing very fast. And as new people are coming into our community, we need to encourage as many of those people as possible to become new contributors. And even if the rate of users who become contributors remains small, we want it to at least be consistent with the growth rate. We don't want it to drop off. So we have new members, we're having lots of new members of the community. Are they going to become new contributors? Because again, all software engineers are programmers, but all programmers don't need to be software engineers, don't want to be software engineers. So that's all I've got. I am very interested in people's feedback. Again, I've been working on this talk for a little over a year, and I've gotten different types of feedback. Some people very angry that no, everyone should be using all the software engineering tools all the time, Kojo. Other people less angry. So if you have any feedback or questions or comments, you can reach me on Twitter as Transition. I think I have that written on my badge, or I'm here for the rest of the conference. So feel free to stop me and ask questions or provide comments. And that's all I've got. Thank you for your time. If we have time for Q&A, I don't want to, no, actually, we got like maybe 3-4 minutes. If there's time for Q&A, I'm happy to answer questions here, or we can talk in the hallway and people can go to break, because I know there's a break scheduled. I am a promoter of what I call the self-care sprint, so if you need a little bit of downtime between this talk and the next talk, feel free to just go and sit quietly somewhere. You don't have to talk to me. So thank you for your time.